Hello everyone. First of all, my name is Adi Waris bin Abdullah Sani from BEET, Section 1, Group 1, Group Lab number 2. So our members is Chan Chin Min and Alisa Azwani. So the topic for Lab 2 is about Hooke's Law. So for objective, to perform on Hooke's Law, to investigate the characteristic and deformation of the spring, to get the response of the spring when an external agent change its equilibrium length by x can be described by Hooke's law, F equal negative kx. So this is just a synopsis theory, single spring, and the second one is two types of spring, tension spring and compression spring. So this one is spring connected in parallel. So this is a parallel spring, and the formula for parallel spring is Kp equals K1 plus K2. And for the for the series spring, the formula for series spring is 1 over Ks equal 1 over K1 plus 1 over K2. So this is the procedure for three parts, part A, part B, and part C. We're using this website for doing the simulation, and this is the step for doing the simulation. Sorry. So after we doing the simulation, we get the result for three parts: part A, part B, and part C. So this is the result for part A, table 1 that we get, and for part B from table 2, the result from table 2, and lastly part C for result from table 3. Okay, and for question in this discussion, we perform a graph and we get the result for three parts as well. So this is graph for part A, and this is for part B. Okay, and last for the part C. Okay, and for the calculation for part B and part C, we calculate for parallel spring for both combination Kp1 and Kp2. So Kp1 we get 450, Kp2 we get 550. For the spring series for both combination Ks1 and Ks2, we get Ks1 we get 111.11, and Ks2 we get 136.36. So number 4 is the percentage difference for parallel spring between both combination Kp1 and Kp2. So the calculation that we get the result, and we get 32.32%. And for the series spring, same as well, between both combination Ks1 and Ks2. We doing the calculation, and we get 22.72%. And for the conclusion about this lab is to perform on Hooke's law. We have been investigate the characteristic and deformation of the spring plus to get response of the spring. However, Hooke's law is a stretch of spring is directly proportional to applied force in symbols F equal Kx, where F is the force, X is the stretch, and K is the constant of proportionality, plus the amount of spring stretches plotted against the weight added to the hanger gives a straight line that goes through the origin. Okay, so we done for our presentation. Thank you.